Alright, here we are with Lesson 12, Angles Associated with Parallel Lines. What you're going to need is a protractor for the first part of this exercise. And you'll need your math journal because you're going to be doing some summarizing of definitions. There's going to be a lot of definitions in this particular lesson. Alright, starting with Exploratory Challenge, Problem 1. Go ahead and read the directions and use your protractor to measure the angles as best as possible, and then when you're done with that, go ahead and continue the video. Alright, for Exploratory Challenge Problem 1, this is what you should have. For these sets of intersecting lines, you should have measured at about 117 degrees and 63 degrees for the intersecting lines, and down here for L2 intersecting line M, 104 degrees and 76 degrees. And then as far as what angle measures are the same, remember the symbol for angle. Angle 1 is equal to angle 3. The reason why we can say equal and not congruent is because we have the actual values of the angles, and so we can say 1 is equal to 3 because of the values, and so on and so forth. The pairs of angles listed are equal because they are vertical angles, and vertical angles are always equal because you can rotate this 180 degrees, and by definition of rotation of 180 degrees, this angle will map itself onto this angle because they preserve, it preserves the degrees when you rotate. Alright, so in your journal, what did you notice about pair of angles in the first diagram when lines L1 and L2 are not parallel? Well, we know that angles 1 and angle 3, 2 and 4, 5 and 7 and 6 and 8 are all vertical angles that are equal in measure. Why are vertical angles equal in measure? It's because we can rotate around the vertex 180 degrees and it maps onto its opposite angle, and since rotations are degree preserving, it means that the angles are equal in measure. Alright, so now based on this definition, we're not looking at the actual angle measurements, but based on this definition, angles that are on the same side of the transversal in corresponding positions in L1 and L2 or below L1 and L2 are called corresponding angles. So without referring to the angle measurements, name a pair of corresponding angles in the diagram. Well, that would be angles 1 and 5, 4 and 8, 2 and 6, and 3 and 7. So based on the definition of corresponding angles, not looking at what the values of the angles are, we can still label corresponding angles, and in this case it's 1 and 5, 4 and 8, 2 and 6, and 3 and 7. Another definition is when angles are on opposite sides of the transversal and between or inside lines L1 and L2, they are called alternate interior angles. So name a pair of alternate interior angles. This would be angles 4 and 6 and 3 and 5. And last, when angles are on opposite sides of the transversal and outside of the parallel lines, above L1 and below L2, they are called alternate exterior angles. Name a pair of alternate exterior angles. That would be angles 1 and 7 and 2 and 8. Alright, so now go ahead and do exploratory challenge number 2. Measure the angles on the diagram, and when you are done answering the questions, continue the video. Alright, so this is what you should have. When you measure the angles, you have 141 and 39 here, and 141 and 39 also. And again, if you're off by a degree or two, you can just go ahead and fix it. But you should notice that what is 141 plus 39? Should equal 180 degrees, just like back in challenge 1, when you add those two the two supplementary angles together, you should also get 180 degrees. But what angles are equal in measure? Well, 1 and 3 and 5 and 7 are equal, and 2, 4, 6, and 8 are equal in measure. So what do you notice about measures angle 1 and 5? Well, 1 and 5 are equal in measure. We can translate angle 1 along the vector line M so that the vertex of angle 1 maps onto the vertex of angle 5. Translations are degree preserving, so the two angles will coincide. And then the same thing description-wise for part B. 3 and 7 are equal in measure, again because of translation. And for 4 and 6, these will be equal because you rotate 180 degrees around the center, and they are degree preserving. This is going to be huge later on when you're asked to describe why parallel lines cut by a transversal create these types of angles. It all goes back to the rigid motions, the basic rigid motions, and you need to be able to describe it in that manner. All right, so we're going to discuss what you observed when you measured and compared angles in Exploratory Challenge 2. So what we will do is make some informal arguments to prove some of the things you noticed. And each time you answer why or how do you know or explain, you are making an informal argument, which is going to lead later on to formal proofs in which you need to be precise in your language. So you are starting the proof process by doing some informal arguments. So were the vertical angles in Exploratory Challenge 2 equal like they were in Exploratory Challenge 1? Why? Well, yes, for the same reason. They were equal in the first diagram because of rotation. So what other angles were equal in the second diagram when lines L1 and L2 were parallel? Well, angles 1, 3, 5, and 7 were the same, and angles 2, 4, 6, and 8 were the same. So let's just look at angles 1 and angle 5. What kind of angles are these, and how do you know? Well, they are corresponding angles by definition because they are on the same side of transversal and in corresponding positions. For example, above each of L1 and L2 or below each of L1 and L2. So we've already said that these two angles are equal in measure. Why is this so? Well, because of translation. We can create a translation along the vector in line M. This will map angle 1 onto angle 5, and because translations preserve degrees of angles, the two angles are equal in measure. What did you notice about angles 3 and angle 7? Well, these two angles are also equal in measure for the same reason as angle 1 and angle 5, by translation. So what other pairs of corresponding angles are in the diagram? Well, angle 4 and angle 8, and angle 2 and angle 6. So in Exploratory Challenge 1, the pairs of corresponding angles we named were not equal in measure. Given the information provided about each diagram, can you think of why this is so? Well, in the first diagram, lines L1 and L2 were not parallel. A translation of one of the angles would not map onto the other angle. So if angle 4 and 6 are corresponding angles, or are they? If not, why not? Well, no, they are not in the same side of the transversal in corresponding locations. So now we're getting to the definition of corresponding angles. So in this case, 4 and 6 are not corresponding because it does not meet the definition of what corresponding angles are. So what kind of angles are angles 4 and 6, and how do you know? Well, angle 4 and 6 are alternate interior angles because they are on the opposite sides of the transversal and inside the lines of L1 and L2. So we've already said that angle 4 and 6 are equal in measure. Why do you think this is so? Well, you can use rotation to map one of the angles onto the other. And why? Because rotations are degree preserving. So So name another pair of alternate interior angles. Well, that would be angle 3 and angle 5. So in Exploratory Challenge 1, the pairs of alternate interior angles we named were not equal in measure. Given the information provided about each diagram, can you think of why this is so? Well, in the first diagram, lines L1 and L2 were not parallel. So a rotation around a point would not map one angle onto the other angle. Are angles 1 and angle 7 corresponding angles? If not, why not? Well, no, they are not on the same side of the transversal, so they cannot be corresponding angles. So are angle 1 and angle 7 alternate interior angles? If not, why not? No, they are not inside the lines of L1 and L2, so they cannot be interior angles. So what kind of angles are angle 1 and angle 7? They are alternate exterior angles because they are on opposite sides of the transversal and are above L1 and below L2. So name another pair of alternate exterior angles. That would be angle 2 and angle 8. So these pairs of alternate exterior angles were not equal in measure in Exploratory Challenge 1. Given the information provided about each diagram, can you think of why this is so? Well, in the first diagram, L1 and L2 are not parallel, and a rotation of one of the angles would not map onto the other angle. If you know that pairs of corresponding angles, alternate interior angles, and alternate exterior angles are congruent, what do you think is true about the lines? Well, the lines are parallel when pairs of corresponding angles, alternate interior angles, and alternate exterior angles are congruent. So let's state the following theorem and its converse. When parallel lines are cut by a transversal, then pairs of corresponding angles are congruent, pairs of alternate interior angles are congruent, and the pairs of alternate exterior angles are congruent. Just look at Exploratory Challenge 2. So the converse, or if we say this backwards in a way, the converse of the theorem states that if you know that corresponding angles are congruent, then you can be sure that the lines cut by a transversal are parallel. So we're starting with the back of the statement, pairs of alternate exterior angles, or actually pairs of corresponding angles, pairs of alternate interior angles, and pairs of alternate exterior angles are congruent. Then we have parallel lines cut by a transversal. So how can you phrase the converse of the theorem with respect to the other types of angles we have learned? And again, just stating the same thing with using alternate interior angles and using alternate exterior angles. So let's go ahead and summarize. When a pair of parallel lines are cut by a transversal, then corresponding angles, alternate interior angles, and alternate exterior angles are equal or congruent. We know that the specific reason pairs of angles are equal is because the properties we have learned about basic rigid motions, specifically that they are degree preserving. And when a pair of non-parallel lines are cut by a transversal, corresponding angles, alternate interior angles, and alternate exterior angles are not equal. All right, we'll see you in class.